Hello everyone, myself Vasudev Gantada from Civil Engineering Department. Today, I am going to explain our project StabiPID. Imagine a simple seesaw. Now imagine it balancing itself automatically.
No matter what the position of ball is.
That's the idea behind StabiPID, a self-regulating balancing system powered by smart control technology. At the heart of StabiPID lies the PID controller, a mathematical brain that continuously calculates how much correction is needed to keep perfect balance. It works with three components: proportional, integral, and derivative control. Together, they ensure fast response, stability, and smooth performance. Here's how system works. A sharp IR sensor detects the position of the object on the seesaw. This data goes into Arduino Nano, which processes it using the PID algorithm. Based on this, servo motor adjusts the tilt of seesaw in real time, keeping the system stable within seconds. Powered by a 12-volt lithium-ion battery and integrated through a custom PCB, StabiPID is designed to handle while maintaining accuracy and speed. This updated version improves upon the earlier prototype developed by our seniors, with faster response, higher accuracy, and an optimized design. Beyond just balancing, this project showcases how control systems like PID are used in robotics, automation, and real-world engineering applications. Stay tuned because in these upcoming episodes, we'll dive into the CAD designs, live demonstrations, and the exciting new updates. This is StabiPID. Thank you.